Okay, so we have to identify the independent and dependent. You need to figure out which one is dependent on the other. So in this example, we're looking at a relationship between total strikeouts and number of innings pitched. Does the total number of strikeouts depend on the innings or the other way around? Do innings depend on strikeouts?
Yes.
Or do the strikeouts, how many strikeouts you get, depend on how many innings there were?
Strikeouts and independent.
Strikeouts depends on the innings. So we would say dependent equals the strikeouts. Raise your hand if you got this right. And independent, I'm just going to put IND, equals the number of innings. Okay? So correct it, please. The strikeouts you get depends on how many innings there are. As the innings increase, what do you think is likely going to happen? Will the number of strikeouts increase or decrease? As you pitch more, do you think you're going to strike more people out? I guess it depends on the team and the game, right? Yes. The number of fish depends on what time of day it is. Maybe what? What do you think? What do you think would happen as?
Maybe they'll catch like 2 fish at 1 p.m.
So the number of fish is dependent. And the independent would be the time of day. Maybe you would catch more fish as the day progresses. As time goes on, it's possible that you're going to catch more fish, right? Because if you're spending more time fishing, as time passes, the number of fish you catch increases, correct? Okay, for C, the relationship between depth of a swimming pool, so how deep the water is, and the time needed to fill it with water. Which one's independent and which one's dependent? Yes. Good. Depth of a swimming pool is what? The depth of the pool depends on the time it takes to fill it up. The more time passes, the deeper the pool, right? So independent would be time. We're trying to come up with an if-then statement. So we're going to look at, for A, the relationship between the amount of time spent babysitting and earnings. So we can say, if the amount of time spent babysitting, would you say increases or decreases? Increases. What happens to earnings? Then the earnings will increase. So what would a graph look like for this one? If time increases, then earnings increases. Yes, positive upwards. As time passes, you're going to make more money. Okay, that's the if-then statement. If the time spent babysitting increases, so if I spend more time babysitting, then I will earn more money. Does that make sense? So we're looking at a relationship between amount of light and a plant's growth. So what's a possible if-then statement? You're using if, and we're looking for words like increase or decrease. So what did you get?
If a get less light than the plant.
Good. So Seraphim said, if a plant gets less light, then it will not grow as fast. So what would that look like?
Negative.
Negative downward. If it's getting less light, then it won't grow as much. So if a plant does not get light, it won't grow that much. Okay, so that would be, I'm glad you chose that one because that's a negative downward trend. So that was a good example. Excellent. How about the last one? Relationship between snowfall and the cost of snow removal. Think about when you have a snowstorm. If lots of snow falls, so if the amount of snow that's falling increases, what do you think will happen to the cost of the snow removal? It will increase. Okay, so if the amount of snow increases, then the cost will increase. What kind of trend will this be? Upward, positive. We need to come up with a title for each axis. So we have an x-axis and a y-axis. And we need to come up with a title for the graph. So let's first look at this data. What type of trend is being shown here? Yes. Negative, downward trend. So I want you to think of something in real life that could show a negative downward trend. Think of a relationship between two things that as one thing increases, the other thing decreases, right? As something increases, something else decreases. The example Daniel gave was, we're looking at time in years and cost in dollars, and you're looking at video games, right? So Daniel said, as time passes, every single year, the price of a video game goes down. Would you guys agree?
Yes.
Okay, can someone think of another example that would show a negative downward trend? Okay, so Shanthan said, as time passes, we're going to cross out this title, the worth, the value of a car goes down. The older the car, the less it's worth. Excellent example, okay? Someone just said sometimes cars that are really, really old are worth a lot of money because they're antiques, right?
Depends on the car.
It depends on the car, depends on a lot of factors, how many kilometers are on the car and what condition it's in. So maybe we might put this point here. I want everyone to put a point on their graph. I want you to circle it, and we talked about this. This is outlying data. It's data that doesn't always follow the trend because of a special circumstance. In this case, maybe that represents an antique car. It wouldn't follow this trend. It's a really old car, but it's worth way more. Okay, does that make sense?
Yes.
Stop right there. We're looking at a table that shows data for 7 students who went door to door and they're trying to collect money. So the first student, how many homes did the first student visit? Julia.
1.
How much money did they earn? $4. Okay? Now let's look at the second person. They visited how many homes? 15 homes, and they made how much money in pledges? So I want you to make a prediction. Look here, please. Just by looking at these first two numbers on in the table, okay? So I want you to make a prediction. What do you think happens as you visit more houses? The more houses you visit, what do you think is going to happen, Shane? You get more money in pledges. Let's see if that's true by graphing it. So where would we put number of houses, on the x-axis or the y-axis? Good. The pledges is dependent. The amount of money you earn that you collect depends on the number of houses visited. Okay, so we need to pick a scale for houses visited. We're not putting these numbers on the x-axis. We're picking a scale. What do you guys want to count by? What'd you count by?
2.
I did by 5.
I did 5.
We need to get up to 25. So
Yeah, 5.
5, 10, 15, 20, 25, sure. 5, 10, 15, 20, 25. And then for the y-axis, so this is x, this is y. The highest number there is 99. We need to get up to 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so I want everyone to plot this data right now, and I'm going to come around and check. 70, 80, 90, 100. I'll do the first one for you. One house, they made $4. It would be somewhere around here. 15 houses, they collected $83. It would be somewhere around here. Okay, so this is what your graph should look like. What do you notice? What is the trend? Is it negative? Is it positive? Is it up? Okay, so I'm going to draw a line here. We're going to talk about this later. This is a line of best fit. Look here, please. I'm going to draw a line that goes through almost all the points. Actually, that's not a good one. Let's redo that.
I lost the graph that I did a lot.
Okay.
Remember when we did it?
So it's helpful to recognize outline data if you draw a line of best fit. I'm drawing a line that's as close to all the points as possible. Do you see that? Which point does not follow the trend? Please raise your hand and don't call out. Which point is outside of most of the data, outside the trend, I mean? Yes. Yes, this point here, I'm gonna circle it. 275 is the answer for B. This is the outlying data. This point does not follow the trend. And what does this mean? The person visited how many houses? 2 houses, and how much money did they earn? Did they collect? Okay, that doesn't really follow the trend because we know that the more houses you visit, the more money you're going to collect. So what could you think could be a possible reason for this value? What do you think might have happened? Maybe this person just got really lucky and the second house they went to, the person was really rich and they decided to give them a lot of money. Maybe they were happy with what the money was going towards. Okay, so for number 5, we're going to sketch a possible scatter plot. So we know that we need an X and a Y axis. So that's the first thing you're going to draw. That shows a person's height over time. So which one would be dependent and which one would be independent? Does your height depend on time passing?
Yes.
Okay, so height is going on the y-axis, and time, let's say in years, so your age, this could be your age, would be on the x-axis. So tell me what is happening. Lorraine, thank you. As time passes, as you get older, your height increases. So what would the points look like? When you're first born, you don't have to put numbers here, but think about it. When you're first born, you're short. Then you get a little taller, taller, taller. It's not going to be perfectly linear. You don't increase in height every single year by the exact same amount. Maybe one year you get taller really quickly because you're going through puberty. And then maybe you get back to not getting tall very quickly, and then eventually you stay the same height. Okay? So as you get older, so as time passes, your height increases. So people grow taller from birth until they reach the adult height. Okay?